Efficient data storage and retrieval are paramount in this ever-changing modern world of tech. In today's episode, you're going to unlock the best data storage methods in Python and find out which method suits your Python data management needs. Let's dive into the episode. Welcome back, guys, to another episode of PyPod Chronicles.
Welcome to PyPod Chronicles, a series that brings our tech blog to life in a whole new way. Covering an array of topics surrounding Python and tech, from programming tips, best practices, and so much more. Let's get immersed in Python with the Nerd Nook on the go.
This is the crossroads where decisions shape destinies, where the choice between a class, a nametuple, or a data class can steer your code towards greatness or mediocrity. In today's episode, we're going to dive into the differences between these, that class, nametuple, and data class, which each approach comes with its own set of pros and cons. As long as you understand when and why to use one, then you're well on your way. Guys, before I dive into today's episode, the link in the description is a boatload of resources for you guys. It is my newsletter, right? On that newsletter is not only the podcast, I have weekly deep dive articles for you breaking things down, as well as my free Python courses, over 30 hours of content dedicated to you guys, taking you from A to Z in your Python journey. If you want more of a variety of things, head on over to Code with Josh on YouTube, as I have weekly episodes and daily shorts coming out. Alright, as always, guys, if you want to show your support for this episode, the link's in the description. That's where to go. They really do help me. A lot of them are free links, other ones you can support by joining my premium stuff. Alright, into the episode. As much as I love data structures and nesting these little buggers, this episode is not on the common data structures we all know and love, like lists, dictionaries, tuples, right? Those built-in guys we have with Python. The data structures I'm talking about now today allow for a whole other level of data storage. Storing classes or objects as elements in these built-in Python structures is how we can take your skills up a step. And in Python, we have several options for storing data on these advanced levels: classes, named tuple, and a data class. Each one of these has its own set of advantages and disadvantages. And by the end of this episode, you're going to have a clear comparison and know which one is best for you and when to use it. Let's start off with a class, a tale of versatility. Coming from Python and OOP, you should know what a class is, alright? If you don't, check out my free 7-hour course on object-oriented programming. Link in the description. But really just imagine a class as the peak of data storage, or the base of data storage, I should say. With its init constructor method, it crafts objects with precision. So we can create a class, we create an init method, our constructor method, which stores all of our properties. But the issue with this is we need to create a boilerplate. This is good sometimes, and while you're honing in your skills, you're diversifying, this is great. Alright, because a class in Python is a blueprint for creating objects. It encapsulates data for objects and functions that operate on their own data. And this allows for our code reusability as well as organization. Classes in Python offer a powerful way to encapsulate your data in behavior of objects. If I were to use a class to store data, I would create a normal class with init, giving it all the properties that our data will hold. But the issue with this, not really an issue, it's just longer, is we also need to create a string representation method using the dunder representation method. Provide a clear representation of that object, so I can use this for debugging or logging, right? But the other one that I typically would need to create in my boilerplate is the equality operator to compare two objects. And this is just going to return true or false. So if I use a class for data storage, it does come with pros, right? Flexibility, encapsulation, inheritance. But the cons of using a class for data storage, well, I need a lot of boilerplate code. I need to manually implement init and my dunder methods for string representation as well as equality. So there's a lot more typing that I gotta do here. Let's go into the next one. So classes we all know and love. Let's talk about a named tuple. It's a convenient way to create a data structure coming from the Python collections module. And it's similar to a tuple but allows accessing elements by name as well as by index. So a named tuple gives you a lightweight way to define a data structure without having to create that full definition of a class we just spoke about. So to get a named tuple going, I'm going to say from collections import named tuple. Okay, and then I'm going to create a class just like I normally would. So like user equals named tuple. All right, user is capitalized. Inside named tuple, I'm going to give it 2 arguments. The first one is the name of my class. The name of the named tuple is a string. And the second one is an iterable, a list. Here is going to be all the values my data structure will hold, like name, age. Now I can create an object just like I normally would if I was working with a class. For example, user1 equals user. Inside user, I would have to give it name and age. Now, the pros with this, well, you guessed it. The compact syntax, all right? It's a single line of code, but it also comes with tuple. What is a tuple? It is an immutable type of data. So a named tuple is immutable. But the cons with a named tuple is it has really limited functionality. All right? And because of those immutable constraints, we can't really do much with it. So it's lightweight, it's quick, it's great for that. But if we want to do more, we should look elsewhere. And long last, the data class. This emerges as the diplomat of data storage because it gracefully redefines and holds our data. So we don't have to worry about all this chaos behind the scenes. If you missed last week's episode, head on back to last week's episode because that's where I really dove into data classes. Data classes are relatively new to Python, all right? But they eliminate the boilerplate code needed with traditional class definitions. They still come packed with all the boilerplate perks we did talk about earlier. So data classes are defined using the data class decorator, which we'll import, and then this automatically generates all those special methods. Init, string rep, quality op, all of those are automatically generated. So to get this going, I would say from data classes, import data class. I'm going to create a class, and then just above it, I'm going to use the data class decorator. Now inside class, it really just looks like a type hinting or a string annotations. I'm going to create the name of a variable and then a colon. After the colon, I'm going to put the type of data. So for example, if I have a class product, I might have 3 variables: item, brand, price. Item is a string, brand is a string, price is an integer. That's it. Okay, so I've created a data class. A data class combines the simplicity of a named tuple with the flexibility of classes. They offer a convenient way of defining data structures with minimal boilerplate code. But they're not always good, so I need to talk about that quickly. The pros of using a data class is its concise syntax. It offers the advantage of mutability, unlike named tuples, and then it automatically generates the methods we need, all that manual implementation we needed to do earlier. But the con of using a data structure is if you're working with older Python code, the compatibility, right? And then while data classes simplify data storage compared to traditional classes, they may introduce complexity if you're not familiar with data classes. So overall, data class is king. It wins, okay? But if you're not used to it, don't jump into it. You need to know how basic classes work. Now, before we leave this episode, when to use which data structure? I've opened you up to this new way to interact and store data. The next most common question I get asked is, when should I be using these? That's an obvious question. Okay, so let's talk about when to use traditional classes. And classes are ideal for situations where complex behaviors and relationships need to be defined. They offer the most flexibility and customization options for you, though, and this makes them great for larger scale applications. When to use a named tuple? Named tuples are best suited for simple data structures, where you're really just focusing on readability and simplicity. And then finally, when to use a data class? Well, a data class, they strike a balance between classes and named tuples. And they're suitable for a wide range of use cases, particularly when defining data-centric applications with minimal boilerplate code. Wow, guys. Let's wrap up today's episode. Choosing the right data structure for storing data in Python, it really depends on the specific requirements of your application. By understanding the strengths and weaknesses I talked about here today, you can make informed decisions on your code. Understanding the pros and cons of these guys, that's going to go a long way. I want you to take what we've learned today, go and explore traditional classes, named tuples, and data classes. All right, which one did you not know? Spend the next 10-15 minutes researching that. Head on over to the link in my description, guys, and read into those articles. I break it down in the best way possible, all for you guys. Well, that wraps up another episode of PyPod Chronicles. I cannot wait to see you guys in next week's episode. If you enjoyed today's episode, do me a favor and like it on whatever platform that you're listening to this on. Until next time, guys.